Good morning. Welcome back to the second module on ECG. Today we are going to discuss on the lead systems, normal waves and intervals. In the last class, we have discussed about invention of electrocardiographic machine by Eindhoven, the modern electrocardiographic machine, how it looks like, and what is the difference between electrocardiogram and graph and the conducting system. We also explained that the machine is a modified galvanometer. And for a galvanometer, there should be an exploring electrode, which is the positive pole of the electrode, and there is a negative pole. So, when connections are made like this, they are called bipolar leads. So, bipolar leads means it has got a positive pole and a negative pole, and positive pole is the exploring electrode. And classically, there are three bipolar limb leads, three unipolar limb leads, and 6 chest leads. And total, there are 12 recordings or connections are made to record the electrocardiogram. And that is why we write standard electrocardiogram, otherwise called 12 lead electrocardiogram. So the standard electrocardiogram, unless you write for specialized leads, the technician records 12 leads. So what are leads? As already mentioned, the leads are the connections from the patient to the machine. So let us see the limb leads. The limb leads are named as lead 1, lead 2 and lead 3. So that is how they are named. Let us see what is lead 1. Lead 1 is the potential difference between the right arm and left arm with the positive pole on the left side. So if you draw, you can draw like this. And you can put a mark like this. I encourage all of you to take a bit of paper and draw this and line. So let us look at lead 2. Lead 2 is the potential difference between the right arm and left foot with the positive pole on the feet. So this is how you represent. This is lead 2 and this is lead 1. And lead 3 is the connection between the left arm and left foot with again with positive. And Eindhoven assumed that the two limbs and the pelvis constitute an equilateral triangle, and this triangle is named later as the Eindhoven's triangle. So you should be able to draw this Eindhoven's triangle. That is, this is lead 1, this is lead 2, and this is lead 3. If you want, you can rearrange this like this. So this is lead 1. You take, this is lead 1. You take lead 2 in such a way that this bisects the lead 1. So this is lead 1, this is lead 2, and you take this lead 3, take it and keep it over here. So this is lead 3. So this is another representation of this electrical activity when it is recorded, and this is called the triaxial reference system. That is triaxial. That means there are 3 axes. This is useful when you learn about the vectors of the heart. So hope it is clear. The lead 1 is the potential difference between the right arm and left arm with the positive on the left side. Lead 2 is the potential difference between the right arm and left foot, and lead 3 is the potential difference between the left arm and left foot. So that is graphically represented like this. So this again, and Eindhoven recorded it from the shoulder and the pelvis, but later it is found that by recording like this, that is by connecting to the limbs, there is not much difference, and this is how the standard electrocardiogram is taken. In the previous session, we described about the volume conduction and electrical activity is conducted, transmitted very well. So from the thorax, as body act as a volume conductor, and so you can record the electrical activity from different parts of the body. You should remember the positive pole of the machine is the exploring electrode, and the electrocardiogram depends upon the exploring electrode. In the last session we said when the current goes towards the positive pole, it will produce a positive reflection. The current goes away, it will produce a negative reflection. That is why you should remember the polarity of the leads. Hope it is clear. Now we will think about in which plane we are looking. These limb leads are in the frontal plane axis. This is in the frontal. You are looking at the patient from different angles. The exploring electrode can be considered like an eye. You are looking into the heart from different directions. In the lead 1, you are looking from the heart from here to here in the frontal plane. In the lead 2, you are looking from here to here, and lead 3 also you are looking from the below upwards. So that is a concept that you should keep in mind. So in short, you should remember bipolar limb leads look into the heart in the frontal plane. From the front it is looking. Whereas the chest leads are looking in the horizontal plane. So that is represented here. That is, you can see there is this is the frontal plane axis. There is another type of lead called the unipolar leads. So last time we had drawn the Einthoven's triangle. So this is the Einthoven's triangle. The unipolar leads are made in such a way that the exploring electrode is a positive and the negative pole is made neutral by some methods. And the recordings are so small, they are augmented. Then it is called augmented unipolar leads. When it is kept on the left arm, it is called AVL. AVL means the positive pole on the left side. When it is kept on the feet, it is called AVF. And when it is kept on the right side, it is called AVR. So this will be the position of the AVL. This will be the AVR, and this will be AVF. So how many limb leads are there? 3 bipolar leads and 3 unipolar leads, and they look into the heart in the frontal plane. You can see in this picture, this is AVL, this is AVR, this is AVF. The previously we have drawn the Einthoven's triangle. We have modified it to a triaxial system. So here this is lead 1, this is lead 2, and this is lead 3. So this is lead 1, this is lead 1, this is lead 2, and this is lead 3. We can keep the unipolar leads also here. So this will be the AVF, and here comes the AVL, and here comes the AVR. Here extend the line like this. And now there are 6 axes. This is called the hex axial reference system, and the heart is sitting here. Again, as I have told you, this concept is important, especially when we learn the vectors of the heart and the various forms of the ECG, how the waves are looking in different leads. Because in each lead, as explained earlier, the exploring electrode can be considered as the eyes, and you are looking at the heart from different angles. Just like we are going to see an elephant, we are looking from different angles and seeing different parts. Now we go to the chest leads. As mentioned earlier, chest leads is a cross-sectional view. So usually we record 6 chest leads. They are named from V1 to V6. So this is V1. V1 is on the right side in the 4th intercostal space. V2 is again on the 4th space but on the left side. V3 is between V2 and V4. V4 is in the midclavicular line in the 5th intercostal space. V5 is in the anterior axillary line again in the fifth space, and V6 is in the mid-axillary line. So these are the routine ECGs or the routine chest leads for a standard electrocardiogram. In certain situations, you ask for special leads. So two of them you should remember. One is the V3R and V4R. V3R means V3 kept on the right side. So this is V3. So he keep the V3 on the right side means it will be on the fifth space in the mid-clavicular line. So this will be the V3R. Not in the mid-clavicular, sorry. The V4 is in the fifth space in the mid-clavicular line, and V3R is between V4 and V1. There is no V1R because V1 is already on the right side. And again, there cannot be no V2R because V2 is actually in the same place is the V1 is kept. So V3R and V4R are two special leads which are ordered when you are suspecting some problem with the right ventricle, or in sometimes in a malposition of the heart like dextrocardia. Again, you may go for these sort of special leads. In certain other situations, we can have a lead in the esophagus, which are called esophageal leads. Or the same way from the sixth space, you can keep it on the posterior axial line behind like that. Behind, you can go like in the same way, you can go and have extra leads. And this picture clearly shows how you are looking in the heart in the horizontal view, the transectional view. So you are looking from the heart from different angles like this in a cross-sectional view. So you can see the V1, V2, V3, V4, V5 and V6, it is looking like this. And each positive poles are looking the heart from different angles. So the ECG in different leads vary. This I already shown. All of you take the paper and draw this and learn it. One point you should learn from here, it is different from the polarity of the leads which we set. Anything above this line is considered negative and below is positive. Don't get confused. This is for the considering the vector. So lead 1, this is for 0 and the opposite edge is 180. And we take the AVF as told earlier. Below lower half is positive. This is 90 plus and the opposite end is minus 90. So this is plus 30. So that is the AVR the other end. And this is T2 is plus 60. So we divide the 360 degrees into different quarters. So AVL is minus 30. Lead 3, the opposite end is minus 60. This is minus 90. Lead 2 opposite end is 120. AVR is minus 150. And the opposite end of lead 1 is 180. So this basic, you remember this, you should be able to draw this x-axis reference system. So you draw a line like this. So this will be lead 1. Easy to draw the, so you remember this is lead 2 and this will be lead 3. Then you keep the AVF, you draw the AVL, you draw the AVR. You extend the lines and you get the x-axis reference system. So learn it and learn by drawing, you keep this concept to your mind. This again we have discussed. When the current goes to the positive pole, this produces a positive deflection. When the current goes away, it produces a negative deflection. And if the current goes perpendicular, what will happen? Suppose you see this is lead 1, positive pole, this is negative. The current is going in this direction. What will happen? Up to this portion, the current is coming to the positive pole, so you get a positive deflection. After the midline, it is going from, when you are looking from here, we look at the current is going away from you, so you get a negative deflection, and both are equal. And such a deflection is called the equiphasic deflection. Equiphasic. Again, the usefulness we will learn when we talk about the vectors of the heart. So now we look at what will be the appearance of the electrocardiogram in various leads. We have already said that As a blind person, we are looking into the heart from different directions. So each one will be feeling or seeing the impulses from a different view or different shape. So the electrocardiogram is the sum total of the electrical force, and the electrical force, because of the massive forces of the left ventricle, it appears to be traveling from right to left. So this will be the electrical force going. So this is what is called the vector. So the vector is the sum total of the electrical activity of the heart. When you are looking from an angle, you will see that the current is going in a particular direction. So look at the lead one. This is going towards. So predominantly the waves are positive, and the T wave will follow the direction of the main QRS. So lead 1 should be dominantly positive. Look at lead 2. The lead 2 will be more in direction with the, so this is the electrical force, and you remember this is lead 1, this will be lead 2, and this will be lead 3, and the current is going in the direction. So the lead 2 will be taller than lead 1 and lead 3. In a normal ECG, the lead 2 should be dominantly positive, and should the voltage or the height should be more than that of this. You should remember, if it is not there, either the heart is abnormal or your connections are wrong. Hope it is clear. This is something you remember. Lead 1 and 2 should be positive. 2 should be more positive than lead 1. Now we look at the chest leads. What will be happening to the chest lead? Look at the V1. Here is the heart. Here is the heart. This part is the right ventricle, and the rest this is the left ventricle. The initial forces are going towards V1. So what will happen? You get a positive deflection. But when finally you see that the massive force are going towards in this direction, so you get a negative deflection. So look at the V2, more forces are towards lead 2, so you get a little more tall, and by V3 it becomes almost positive. So this is what is called the normal progression of the R wave. So in the chest leads, if you take from V1 to this R wave height gradually increases. By the time it reaches V3 and V4, the most of the force are in the direction of these leads, and a predominantly negative deflection will become positive. This is called the normal progression. Normal progression of the R wave. This is something which you should always check. Now we go into some features of the ECG paper. To know this is important to calculate the rate and other things and the intervals. As you know, the electrocardiogram, the recording is by a stylus. This is stylus. The stylus is heated. This ECG paper is nothing but graph paper. It's a graph paper coated with wax. Once the heated stylus is moving, it will be producing electrical activities like this. If there is no electrical activity, the stylus will remain fixed, and the paper is moving, and you will get isoelectric. Hope it is clear. That is, ECG paper is a wax coated graph paper, and this paper is running at a speed of 25 small divisions per second. So the x-axis will be the time. That is, paper is running at a speed of 25 small divisions per second. You can see this graph paper. Every fifth one will be a little bold one, and it contains 5 small divisions. So 25 small divisions per second. So what will be the duration of one small division? Anybody can say? Easy to calculate. 1 by 25 is equal to 0.04 seconds or 40 milliseconds. This value you should remember, 0.04. One small division is 0.04, and one large division will be 0.04 into 5 is equal to 0.2. So this you should remember. That is, each small division is 0.04 seconds, and one big division or a big box is 0.04 into 5 is equal to 0.2 seconds. And the y-axis determines, or y-axis is the voltage. In a normal recording, when 1 millivolt of current is applied, this will produce deflection of 10 millimeters. So The height or the y-axis is the voltage. 1 millivolt produces deflection of 10 millimeters. So one small division is 0.1 millivolt. So this is what we have explained. So this is a large division. This contains 5 small divisions. One large division will be 0.2 seconds and one small division will be 0.04 seconds. And one small division is 0.1 millivolt. This is basics of the ECG paper that you should remember. So in 3 seconds, how many divisions will be there? The paper is running at a speed of 25 small divisions per second. So 25 divisions per second. So 1 second is 25 small divisions is equal to 5 large divisions. So 3 seconds is 3 into 5 is equal to 15. So 15 small division is equal to 3 seconds. 30 big divisions equal 6 seconds. The advantage is when you are calculating the heart rate, especially the heart rate is irregular, we can count the electrocardiogram or the QRS complex in 6 seconds and multiply with 10. That will give the heart rate. We'll explain this in little more detail while we discuss rate. So now coming to the time duration, certain duration and intervals you should learn it by heart. Of which one of the very important thing is the PR interval. The normal PR interval is, so it should be less than 0.2 seconds and should be more than 0.12 seconds. It's easier to remember as divisions. So 0.12 is equal to 0.12 is 0.04 into 3 is 0.12. So the PR interval should be more than 3 divisions. This you should remember by heart. PR interval normal should be more than 3 divisions. If less than 3 divisions is a short PR interval. And PR interval should be less than 0.2 seconds, that is less than 5 divisions. So 3 to 5 divisions. 3 and 5 are important in cardiology. 3 minimum, it should be 3 divisions for 0.12 seconds, maximum 0.2 seconds or 5 small divisions. If it is less than 0.12, it is short PR interval. More than 0.2, we call it as prolonged PR interval. Second duration you should remember is the duration of the QRS. QRS is called narrow and broad. Narrow means it will be less than 0.12. 0.12 is 3 divisions. So QRS complex again should be less than 3 divisions. Actually it is less than 2.5, but you cannot calculate the 2.5, so we take it as 3. If it is 3 or more, it is abnormal. So you can remember the PR interval, the 0.12. So same thing will be, you remember, should be the QRS complex should be less than 0.12 or 3 divisions. If it's more, it is a broad complex. Hope it is clear to you. We will remember the duration of the P and other things. So the normal P will be discussed in detail when you discuss about the various waves. We said about the concept of isoelectric line. That is, the stylus is moving and there is no electrical activity. That line is called the isoelectric line. Now we think about the waves. One is the PR, the P wave. The P wave should be usually less than 2.5 divisions. That is the usual size of the P wave. The duration should be less than 2.5 divisions. And the height is also almost same thing. It is less than 2.5 divisions. QRS already we have mentioned. The QRS complex should not be broader than 3 divisions. Then one word regarding the calibration. We already said the y-axis is the voltage. The machine is set in such a way that when 1 millivolt current is applied, this will produce a deflection of 10 millimeters. This is called the normal standardization. Sometimes the ECG may be very tall, and in such conditions you uphold what is called the half standardization. That is, the machine is adjusted in such a way that when 1 millivolt is applied, this only produces one division, that is 0.5, or only 5 millimeter deflection is produced. Normally, 1 millivolt will produce deflection of 10 millimeters. Some days you may get some artifacts. This will be again discussed in detail when you discuss about normal ECG. So when you are recording, this is the typical electrocardiogram. You can see the P wave, the QRS complex, T wave, and they are coming regularly. Each QRS complex is preceded by a P wave. So, friends, we have discussed about the lead systems, the 12 leads, 3 limb leads, 3 unipolar leads, plus 6 chest leads. These two are in the frontal plane, and chest leads are in the horizontal plane, and sometimes we use the special leads. So we discussed about the plane and an overview of the normal electrocardiogram we have discussed, and the details of the normal ECG we will be discussing in next session. So this is the end of the module 2, and in module 3 we will discuss about the vector of the heart, and the following sessions we will discuss about the normal ECG and rules related to normal ECG.